So when you are solving for a specific variable and you have a literal equation, these are when we have equations that have two or more variables in them. Your goal is to isolate whatever variable it's telling you. So in these first couple problems, it's telling you to solve the equation for y. So that means we want to get y on one side of the equal sign and everything else on the other. So my suggestion is not to work with the variable first that you're trying to solve for. Try to get everything else away from it. So in numbers 1, 2, and 3, we have adding and subtracting that are near the y that we have to get rid of. We have to get those variables away first. So in number 1, the first thing I would do is I would take the 2x, and that's what we got to get rid of. So if you have a positive 2x, to get rid of that positive 2x, you're going to subtract 2x from both sides. So subtract 2x and subtract 2x. Now, when you are solving for a variable in this instance, and we're going to isolate that y on the one side, I like to put my x's as next to my equal sign just to get practice for writing it in what we call slope-intercept form. So this one, you have the negative 2x and then you have the negative 9. So I'm putting those together. Since they're not like terms, I can't simplify anything else. This is it. This problem is now solved for y. There's a bit more going on in this next problem. So again, I'm going to work with my x, and I'm going to subtract 4x from both sides. So minus 4x there, minus 4x there. So instead of just having y already isolated, I see that I have the term negative 10y. So negative 10y equals, and then I have the negative 4x and a positive 12 here. Not like terms, can't put them together, so I'm just going to write negative 4x, positive 12. It's writing my equation for me. So I want to get the y by itself. So it's being multiplied by negative 10, so divide by negative 10. The way equations work, you have to, what you do to one side, you have to do to the complete other side. So not only is negative 4x being divided by negative 10, but so is 12 being divided by negative 10. So in the first one here, you have, if you take negative 4x over a negative 10, you're going to get, it's going to look like this, negative 4/10 x, which we are going to reduce to negative 2/5 x. You can also write it as negative 2x over 5. That's also acceptable. When you have 12 over negative 10, I'm also going to reduce that, and I'm going to keep it as negative 6/5. You don't actually have to change that to a mixed number, not for us, not for now, so you can leave it as negative 6/5. So when you have a variable you're going to solve for, this one, all you would do is divide by L and H to get the V by itself, or excuse me, to get the W by itself. So I'm going to divide both sides by LH. Okay, L divided by L is 1, H divided by H is 1. You're left with the W that you're looking for. And then on the left-hand side, it does say V divided by LH. When I look at these, I literally just look and say, all right, well, I'm taking that whole quantity, dividing it by LH. That's what I'm going to write it as, because there's nothing to simplify. In this next one, we have F equals 1/2 times the quantity of R plus 6.5. Couple different ways you can go about solving this one. One way you can do it is to distribute the 1/2, but that's a little bit extra work that you don't need to do. So this is actually one big term right here, because you have 1/2 times this whole quantity, So if I wanted to get rid of that 1/2, I could divide by a half. Dividing by 1/2 is the same thing as multiplying by 2. So if I take this side of the equal sign and multiply it by 2, and do that to this side, so times 2, I'm going to have 2f on this side equals, and then 2 times a half makes it 1. And then the r plus 6.5 that's in parentheses is now out of parentheses. I don't distribute this to both terms because I am already getting rid of the 2 by multiplying it by the 1/2 here. So now when we look down here, we have 2f equals r plus 6.5. So we're going to subtract 6.5 from both sides. So now we've isolated the r. And I'm going to write it as 2f minus 6.5. And then the last one. You guys can do number 3 on your own. Here I'm looking to solve for h. We had a very similar problem to this in our notes. So I look at it and I have two, what I like to call chunks, but they're like two terms, two different terms here. So I'm going to get rid of this first term by subtracting 2 pi r squared from both sides, minus 2 pi r squared. So that's gone. So drop my equal sign down. So on the left side here, I have s, I have that value, minus 2 pi r squared. So s minus 2 pi r squared. And then on this side, I have this other term, this 2 pi r h. It's telling me I want to solve for h, which I believe in our notes was L. Same thing. So I have 2 times pi times r times h. To undo that 2 pi and r that are stuck to the h, I can divide by 2 pi r. And I can divide this side by 2 pi r. So that's gone, so you're left with h. Because 2 divided by 2 is 1, pi divided by pi is 1, r divided by r is 1. So all I want is 1h. Drop down my equals. Here's the part where it gets kind of tricky. So when you see this, what you're actually doing is you're taking s and dividing it by 2 pi r, and you're taking negative 2 pi r squared and dividing it by 2 pi r, because you, in this numerator, you have 2 terms. So you have to divide both terms by 2 pi r. So if we rewrite that out, and I'm going to just do it down here, s divided by 2 pi r, and then negative 2 pi r squared divided by 2 pi r. Well, s divided by 2 pi r, this first term that I have, nothing can be simplified. There's nothing in the numerator that can simplify with the denominator. But if I look at this term over here, this second term, I have a negative 2 and a positive 2. That can reduce to a negative 1. Okay, so I'm going to reduce that to a negative 1. I have a pi divided by pi. That can reduce to a 1. I have r squared divided by r. Well, r squared is the same thing as r divided by r, or excuse me, r times r, and I'm dividing that by r. I can take a factor of r out. So in this instance, when I take that factor of r out, I'm left with just one r. So here, when I go back to write it, when I go back to simplify it, my first term, this one right here, s divided by 2 pi r, stays. S divided by 2 pi r. Minus, take my minus sign. Now I'm looking at my next term here. In my numerator, I have negative 1 and an r. So that's minus 1r. I forgot to change it back to black. 1r. And then I have absolutely nothing in the denominator. Everything turned to 1, 1, 1, 1. So I'm going to leave it as minus r. So instead of having it be little like that, we're going to make it a full term. So it's s over 2 pi r minus r equals h. That is that one simplified. So anytime you're doing this, work with the variable that you're trying to isolate last, and then you have to add and subtract from both sides or multiply and divide from both sides in order to isolate that variable.